Welcome back to Ratty Tutorials. We're going to go over the MSP430 software portion of the Secure Garage Door Raspberry Pi project today. So, in detail, we're going to go over installing Energia, which is the software interface and how we program in C. And it's very similar to the Arduino's interface, almost identical. Then I'm going to run through all of the code that is written that you can download online for the MSP430, and we're going to talk about a little issue about the receive buffer workaround and why that was an issue, and then we're going to actually program the MSP430. And as always, if you have any questions, please post them to the writytutorials.freeforums.net, and hopefully I can answer them as soon as possible. Alright, so downloading Energia. Let's Google that. So based off their website right here, you can go to their download page and then download it for whatever operating system you are using. So I've already downloaded Energia right here. I have unzipped it into a folder somewhere secure, and then I've got it right here as my exe. So after opening up my garage door project, this is what I've written, the code. So let's describe the software. Alright, so we're going to go line by line. Hopefully I can describe this in a very simple to understand way, but again, if you have any questions, please post them to the forum. Alright, so getting into our defines. So we're going to define LED, this is just a name, as 15. That's pin number 15. So I have an LED on the MSP430, as we'll see whenever we get to the hardware section. That kind of helps notify me when different states occur. So here is the pinout for the launchpad, the MSP430, and pin 15 is right here. And so this pin, all it's saying is that I'm going to connect my LED right here, and I can turn it on and off. Okay? Then we're going to define different variables. So I'm defining my correct hash. Alright, this is the hard-coded password that you do not want to give out to let anybody know, just you. Alright, so essentially we had generated this hash in the previous tutorial, and you'll post that as a string right here. And then we're going to define an integer garage, and that's going to be pin 5. And then right here, integer. So going back to here, on pin 5 right here is where I'm going to be connecting my actual garage door. And that, whenever that pin goes live, goes on, that's how I open up the garage door. Alright, then I'm going to define a character string. This is essentially a string, but it's an array of characters. It's called my input hash, so this is what I'm going to store the information I receive over UART into this array, and it's going to be 32 bytes long. So it's 32 bytes, 32 characters right here. Alright, and then I'm going to set it as empty right now, just configuring it. Alright, into the setup. For setup, we're going to do serial begin 9600. So this is beginning the UART connection at 9600 baud. You can read into what baud means and what you can do with that later on, but we're going to set it to 9600. That's pretty default for most devices. Then we're going to set our pin mode to our LED as an output. I'm turning my LED on and off. It's considered an output. And then, like I said before, that I'm using this LED on the board as a status, so whenever I turn power on, I can blink my LED right here with this function, and it's kind of just a status telling me that I've turned my device on. So 200 represents 200 milliseconds. Let's go down to this function right here called LED blink. So I've declared my LED blink function, an integer D, which stands for delay. I'm going to set my digital write. I'm going to write my LED low, delay for 200 milliseconds, and then set it high and delay for 200 milliseconds. Basically, that's going to blink my LED at 200 milliseconds. It's going to be really fast. That just tells me that the power is on, okay? Now we get into the infinite loop where the code runs. Now this infinite loop just goes from right here to right here. It's a very short code. There's not much needed here, but let's break it down now. So the first thing it's going to do, it's going to say if serial.available. What this is saying is that information coming in over UART. It's asking if I'm getting any information coming in over UART. If I'm not getting anything over UART, then I'm just going to delay 100 milliseconds and then come back and check again. I don't want to be checking the serial.available instantaneously. You have to have some kind of delay in there. So it's going to sit dormant pretty much 99% of its life, just sitting dormant, waiting for a UART to come in. Now as soon as UART comes in over the Raspberry Pi, it's getting a hash coming in. It's going to blink the LED, just letting you know that, hey, I'm getting information coming in. And this is just for test purposes. And then I'm going to set an integer. Set is my name, and I'm going to put it as serial.available, which is saying how many bytes came in over the UART line. And it should be 32, remember? If I'm receiving a hash, then I'm going to get 32 bytes. Then it's going to say if set is equal to 32, then I'm going to execute this command. Now, if I got input over UART, but it wasn't equal to 32, maybe I got some noise, or maybe somebody's trying to hack me and they sent me something longer or something shorter than that, then I don't want to accept this command. Okay? I'm going to skip over this. If it's shorter or longer, I'm going to delay 20 seconds to discourage brute force attacks. So as one of our other objectives previously is to discourage brute force attacks. What this is saying is that I'm only accepting inputs over serial every 20 seconds. So that means that somebody can't just send me 100,000 hashes in a second or something like that. So I'm only accepting hashes every 20 seconds. Alright. So if somebody sent me something that was false, I'm going to wait 20 seconds, so he can't send me anything else until 20 seconds is up, and then I'm going to clear the buffer. Oop. I'm going to clear the buffer, and what that means is that I have, stuff in my buffer. I got information over the UART, but it wasn't 32 bytes long, it was something else, so I just want to get rid of it. I don't really care what it is, I'm not even going to look at it. And so there is a command that essentially should do this. It's called serial.flush, and that should flush the buffer and get rid of everything, but for some reason this command has not been working on the MSP430. So this little while loop right here will do the exact same thing as flush the buffer. It's just going to say while I have information in the buffer, I'm going to read it, and that's going to clear my buffer. And so once that's completely cleared, then I'm going to go back and continue normal operation. Alright, so let's say we actually got a real command in. We got a hash. It might not be the right hash, but it's 32 bytes long, so we're ready to read it and look into it. So I'm going to serial.readBytes. I'm going to read the information in the buffer. I'm going to read it from input hash. Remember, input hash can take 32 bytes. I'm going to store that information here, and I'm going to store 32 bytes. So I'm saying I'm storing the information into input hash, and I'm storing 32 bytes. I'm reading 32 bytes. Alright, so I have the information now. I have my input hash and I have my correct hash. So now I want to compare the two to see if it's the correct hash and if I'm ready to open up my garage. So I'm going to run through a for loop 32 times. Here's the set again. And then I'm going to compare each character in my hash one at a time until all of them are correct. And if they're all correct, then I'm going to open up the garage. So I'm going to do 4, starting from 0, going to 32, increments of 1. If my input hash, the first character, is not equal to the correct hash, so if the first character is not equal to each other, then I'm going to break out of here because it was wrong. Okay? So if I get D is my first character, now say my input hash is something else. Let's try to write an example here. So say this is the hash that I got in, something like that. You can't have an H. That doesn't make sense. That's not binary. Okay, so say this is the hash that I got in, and this was my input. Okay, so the first character, it did not match up correctly. So I'm going to say this is not equal to that, so I'm going to break out of here. Get out, because it was the incorrect hash, so I don't care. Now, if it was the correct number, say this was a D, like that. Okay, so these match up now, the first two match up. Then I'm going to increment again through this loop for the next value inside of my input hash. So I'm going to go to the next one. So I'm going to look at this one. I'm going to say this is 4, this is the correct one, and then this is my input, and it's a 1. They're not equal to each other. Okay, so now I'm going to break out because they're not equal to each other. You get the picture. So it's going to go down the entire line, and if one character down that line is not equal to the other, then it's going to break out because it was the wrong hash. Now, if it is the right hash, and it goes through this entire loop and it never breaks, then it's going to get to a value, the I is going to keep on incrementing until it gets to a value of 31. And 31 is the last value. So 31 means that I got to 4 right here, I checked them both, they're good, okay? So that means I've gotten to the end. And if I've gotten to the end and they've all been equal to each other, then I'm ready to open up my garage. That's my function right there called open garage. And what open garage does is it sets my pin mode garage, which is pin number 5, remember? And I'm going to set it to an output. I'm going to write to my garage. I'm going to say high. I'm setting the pin high, essentially like putting your finger on it and pressing down, putting your finger on the button and pressing down for 1 second. And then I'm going to set my pin mode back to input. This is a little different way of doing things. Normally you would want to do digital write garage low after this, kind of like you did for the LED right here. But this is a little different. So setting pin mode to an output means I'm ready to push the button down. So I push the button down, and if I set it to input, then that's like me releasing my finger from the device. So a little different method, but it works really well. Alright, so I open my garage, I get out of here, wait 20 seconds to receive another input, and it continues normal operation. So this is an infinite loop. Completely self-sustaining. It won't ever run into any infinite while loops. You don't ever have to reset it. It works really well. Alright, I wanted to talk real quickly over the code to operate the servo motor that I had as an example previously. So inside of the open garage function, this is the old code to use like a button to open it. So I'm just digitally writing a pin down and up, and that will open up the garage door for maybe a relay or something, but this is how you do it for a servo motor. So looking at the top here, we have our first value, servo power, which is pin 6. And remember back in the schematic that we have a MOSFET right here powering the servo, and then we have also signal telling the servo which position to be in. So this is pin 6, powering the MOSFET. Alright, and then servo, my servo, like that. And I'm just grabbing these from example codes for Energia for servos. And then we have the 2 positions of our servo motor. So 5 would be the off state, and 120 would be actually clicking the button. And you're just going to have to modify these variables as you test the code to figure out where the exact position will be to click your button. Alright, and then let's see, digital write, or pin mode, servo power, it's an output. Okay, and then this is just a digital GPIO. And we're going to set it low first so it's not powered on. Okay, my servo attach 9, so pin 9 is this signal line right here. That'd be pin 9. So I'm attaching my signal line. And let's see, so once a hash gets accepted, then we're going to run the open garage function right here. So look inside garage door. So now we're going to write digital write servo power high. So we just wrote this pin right here high, so power is on. And and then we're going to put our first position. So right position 1. So my apologies, I had these backwards. So 5 is the button being clicked. 120 is the button not being clicked. So we're going to put position 1 first, so 5, and that's going to click the button for half a second, and then we're going to put it back to the open state, and then hold that there for a second, and then digital write servo power low, so we're powering this down so that there's no more power going to the servo. So we essentially put the knife to go down, up, and turned it off. So that's how you implement the servo, but then you can also do just a regular digital input output pin here for a relay or something like that. Alright, so again, this is a lot of information to throw at you, but if you have any questions, please post it to the forum and I can go into a little more detail about how this operates. But we have a receive buffer workaround, okay? So you know how we read the bytes in right here from the serial buffer, we read 32 bytes in here, okay? So the 32 essentially means that I want to read 32 bytes from my buffer. But the issue with the MSP430 is that by default it can only accept 16 bytes at a time. So what's going to happen is if I'm trying to put 32 bytes into a buffer that only accepts 16 bytes, I'm going to override it, and then I'm never going to be able to read the right value. Whenever I was running experiments and tests on this, it was only reading the back end of 16 bytes. What was it doing? No, it was reading the first 16 bytes right here, and then it was crashing because it filled up the buffer and it couldn't get all this. So what we want to do is we want to go in and manually configure the buffer and just extend it out more. So let's do that. To do that, you got to do a little workaround here. You got to go into your Energia file or folder right here. So go into your folder and we're going to go find a file called hardwareserial.cpp, and we're going to change a little setting in there. So we're going to go into hardware, MSP430, course, MSP430, and then we're going to go find hardwareserial.cpp. Alright, so open this in your favorite editor. I love Notepad++, but I understand there's better ones out there. And we're going to bring it over here. And then if you read through all this text, it's a jumbled mess. I didn't write it. But you'll find here on line 48 for me, but you can just Google or you can just search it. Define serial buffer size 16. Ugh, that's an issue there. So what I do is I'll just go in there and change it to 64 just to make sure that 32 bytes will make its way into there. So change that to 64, save it, and then exit out of there. And that will fix an issue that you'll get with that. Alright, so we've gone over, we installed Energia, kind of went over the software, fixed the buffer workaround. Now let's program the MSP430. Alright, so let's run a verify. We're going to check. Compiling sketch. Done compiling, no errors. We're golden. Now I can hit upload. Let's see if it will. Oh, well, before you do that, I should have done this first. So just make sure that you have the correct MSP430. Everything's good. Serial port, I'm plugged in over COM1. Good. It means that the device is plugged in. And then select which board you have. So I have the MSP430G2452 right now. But read the top of your microcontroller right here. The top of it, just look at the number right here, and it will tell you which one it is. Just make sure you select the right number on that, and you'll be golden. You'll probably be one of these two right here if you have the launchpad. Just make sure you have the right one. Then hit compile, and it's going to install it onto the chip. And now we are ready, done uploading, erase, program, done, we're all good to go. Now we're ready to move on to the next section, which is to take the chip off of the launchpad and plug it in to a breadboard and wire this thing up. Alright, let's go over the process for how to enable UART on your Raspberry Pi. By default, it is not enabled, so in order to send the hash over, it won't work until you enable it. So our first step is going to be sudo rasb config. Alright. Then you're going to go down to advanced options, you're going to go to serial, and then you're going to click no. Alright. Serial interface is disabled. Alright, you'll go to finish, it'll ask you if you reboot, go ahead and hit no. So then you're going to go to sudo nano boot config.txt, then go all the way to the bottom. You can hit page down on your keyboard and it'll take you all the way down. And then under enable UART right here, you're going to hit 1, Control X. Do you want to save? Yes, hit Y, and then hit enter to save it as the same name. So then now you can do a sudo reboot. Alright, now that it has been rebooted, we're going to have to start to talk about how UART works on the Raspberry Pi. So let's do an ls dev, okay? Like that. So now these are all the different peripherals or interfaces on your Raspberry Pi. But the one we're specifically looking at is TTY-AMA0. This is your UART interface. Alright, so let's dig a little deeper to look at what that interface is. You can do ls tacl dev and then TTY-AMAO, like that, okay? So we're going to look at this a little more. So the owner is root, and its group is called dial out. So if I ever want to use this serial interface, I have to be inside of the group called dial out. Alright, this is important. So then it's important because if we look back at our PHP code where we run this command right here called python flagwave.py, this Python script is running UART, right? And so this entire script is being executed as a user. Could you guess which user it is? Would you think Garage is the user that's executing this? You'd be surprised that it's actually, let's look at all the users again. So we can do sudo cat etsy shadow. So these are all the users on the computer. So you would think that this script is being executed as Garage, but since it's on the Apache server and the Apache server is executing the script, it's actually www data. So this is the user that is executing this Python script. So if this user right here is not inside of the dial out group, then serial UART UART will never work. So we need to ensure that this user has the correct privileges. You can check that by doing id www data. And so I already added him to the dial out group, but when you do it, these are the only groups he'll be in. And he's not inside of the root group, thank goodness, because then you'd be giving anybody with access to your Apache web server root access, which is no bueno. So to add www data to the dial out group, which allows him to use UART, we can run this command called sudo user modify mod, A for append, we're adding something new, capital G for big group, we're going to add, so we're saying the dial out group, and we're going to add them to www data, just like that, okay? So we're appending a new group, dial out to www data. Alright? Boom. So now whenever you run id www data, he'll be inside the dial out group. This should be all of the information you need now to make this work. And to actually make this stick, you're going to have to do a sudo reboot, and then everything should be working fine.